definition for this project. So concurrent engineering, also known as simultaneous engineering, is a method of designing and developing a product in which the different stages run simultaneously rather than conservatively. It decreases product development in time and also the time of market, leading to improved productive and reduced costs. So for this project using the 3D scanning, the 3D scanning is the process of analyze a real world object or environment to collect the data on its shape and possibly its appearance, and the collected data can be used to construct digital 3D model. So for this project, we're using the Glade air freshener. So Glade is an Johnson & Son brand of household air freshener that were first introduced in 1959. So the family of product include aerosol spray, candles, car scents, so such many things. Then Glade is a worldwide brand known variously around the world as Glade in Germany, France, Netherlands. So brand was named Glade in Germany in 2012. So the objective of the project here to analyze the 3D modeling of product to the data or its shape, and to study the process of the 3D scanner. My name is Muhammad Akram Asri, and today I will present about the product review of the automatic fragrance by Glade. So the function for this home appliance, that it can spray the perfume to the home living, so that our home and our living room will become fresh and in good environment. Okay, so the function is divided by two. Firstly, the automatic and manual. The automatic, we can set the fragrance into the certain period so that they automatically spray the perfume when we does not operate it by manual. So secondly, by the manual press, and it will burst the perfume to the living room. Okay, so this automatic fragrance, they have contained a tin that we can refill if it has been out of empty, so that the tin we can refill, and it friendly for user and can keep our home clean and fresh. Okay, so the part that we chose to conduct the project is the only front cover for the automatic fragrance by Glade.
Hello, my name is Andy O'Brien, and I am from Reverse Engineering Concurrent Section 2. So I will be present about methodology. So basically, the general method of by using reverse engineering is the first step. These are basically a 5 steps. So step 1 is basically determine the purpose and design goals, and step 2 is observe and develop ideas of how it works. And after that, we disassemble it into a basic component, and then we analyze it by analyze its function, its material, and how it's manufactured. Then after that, we can make a report of the product design. I will be present this in my slides. So this is basically the method that we use, the procedure that we use. So basically, we use a black and white custom stickers from the company for it to detect the product. We place it into the product. We basically stick it into the product, and then after that, we align the product and the machine for it to capture the images. So after that, it will come up into the Atmos GOM software, and we repeat the procedure until we get the actual product, the complete set of images product. So after that, we remove the unnecessary excess of images like this, and then we convert it into the STL file, and then so we can fabricate it.
My name is Muhammad Azrin bin Muhammad Yusof. So my part is about discussion. So in this chapter, the result from each process stage undergo in the project will be presented more clearly. This is to show that each step represents the progress of the work and will build up to the final result obtained that will satisfy the main objective of our project. The product that have been completely scanned using by Atos 3D scanner machine. The scanning result. The scan from the 3D model is a multiple combination of picture snaps that combine together by the software to produce a 3D model, as shown in the figure. An object of part that have been scanned, such as the front cover of the automatic fragment, use a lot of picture taken from multiple angles to capture the surface detail of the object, as shown in the figure. Each of the picture represents a data cloud point that is used in combining the cloud point as it assigned with a coordinate that is used in determining which picture snap is positioned in the 3D scan, as shown in the figure. Dotted mark or sticker to scan the product that attached to the part to scan give a big impact of the scanning result. The green one. The chosen part have been through many times of scan process in order to get complete scan each of part. The hole at the surface of the 3D scan model is due to the use of marker sticker that act as a reference point for the 3D scan camera in order to identify the object and assign coordinate for the picture snap. Without the reference point, the 3D scanner camera would not be able to identify the object surface, making it unable to snap the picture. Based on the 3D model obtained from the Atos software, an additional process need to be done in order to improve the quality of the 3D model because the result of the 3D scan is to rough surface and with holes that need to be closed off to be a complete 3D model by using gum inspect. Placement of part during the scanning process influence the ability of the scanner to attach the actual scanner product. The distance between part to scan and the auto scanner must be fixed, and only the rotation of the product can be the distance between part to scan and the auto scanner must be fixed, and the only rotation of the product can be adjusted, which is when the other surface is cannot touch the scanner, so we have to adjust the angle and rotate the product to make sure the surface is clearly scanned by the Atos 3D scanner.
Assalamualaikum, my name is Amisha bin Maksha. For this presentation, I will cover the drawing and CAD data. Okay, after the process 3D scanning, okay, we need to make a post-processing for the scanner part by GOM inspect software. Then convert the surface to 3D and edit the part. Okay, here we have Atos file that generated by Atos software after we scan the part. Okay, then GOM inspect file, STL file, and SolidWorks part. Okay, for the Atos file, okay, this the Atos file, original and pure, so we just need the MV pure part only, so the surface that unnecessary, we need to remove it manually. Then we use GOM inspect to make a simple edit to close the hole at the MV pure part and smooth the surface. So this is the finished part that edited by GOM inspect. Okay, after that we need to convert this GOM inspect to STL file. Then STL file we can open by SolidWorks. This is the STL file that we open by SolidWorks. Okay, next, and we can make a mesh prep wizard, curve wizard, and surface wizard. For mesh prep wizard, we can repair the surface. Then we use surface wizard. It can add line from one red dot to other red dot. Then repair the curve by curve wizard. After that, we can get 3D sketch and create loop. So this is the finished edited part. That's all from me. Thank you.
Okay, for the conclusion, the experiment is carried out to see the effectiveness of 3D modeling of the product to get the data of its shapes. So, the operational of 3D scanning in this project by using the Glade Pure Air Freshener. So, the method that being used in this project, firstly, black and white custom sticker was put into the specimen surface to detect the for scanning. Secondly, setting up Atmos machine for 3D capture. And lastly, by using 3D GOM software, the specimen was scanned multiple times by different angle, and after scan, the drawing was edited by removing the unnecessary scan part.